How many squares are there in the 15th pattern? If you want to give this question a go, pause the video. This is a quadratic sequences question, by the way. So let's have a look at what's happening in this pattern. In the first pattern, we have 1 square. In the second pattern, we have 4 squares, so we've added on 3. In the third pattern, we have 10 squares, and we've added on 2 extra squares on each leg. So in the fourth pattern, it seems that we're going to be adding on 3 more squares to each leg. So if we draw this out quickly, okay, there we go. That would be pattern 4. And you see now on each leg of this kind of T shape, we have 6 squares. So we've gone 0, 1, 3, 6 on each leg. So what are the total of the squares in each pattern? So let's write down our sequence so far. We've got 1, 4, that would be 10, and then 6 times 3 plus 1 is 19. This is our sequence so far, and we want to find the nth term, or the pattern to this sequence. To do that, for a quadratic sequence, what you want to do is find the second difference. Start off by finding the difference between the terms. So the difference between 1 and 4 is 3. Then 4 to 10 is 6. Then 10 to 19 is 9. And then we look at the difference between those differences. So 3 to 6 is 3, then 6 to 9 is 3. In a quadratic sequence, the second difference here is always going to be the same. So this was the first difference, and this is the second difference. Okay. All right. Now let's remind ourselves that a quadratic sequence will follow a pattern that looks like this. So an squared plus bn plus c. That's the general form of a quadratic expression. And the goal here is to find the coefficients. So a, the coefficient of n squared, b, the coefficient of n, and c also. A is where you start. To find a, we use the second difference. So it's always the case that 2a is going to equal the second difference. All right. So this is a process you can always follow. So if 2a equals the second difference, in this case we have 2a equals 3. So then we know a equals 3 on 2. All right, so we have our first part of this problem, first part of this quadratic expression. We have a, the coefficient of n squared. The next one you can find is c. So c is, you can think of c as the 0th term. What do I mean by the 0th term? That's the term that if you went to the left, it would be the next term on the other side of 1. How do we get there? Well, let's use the second difference. So it would still be 3 here. And let's rub these out actually. Make a bit more room for ourselves. So we would subtract 3 from 3. So our first difference would be 0. So if we subtract 0 from 1, the 0th term would be 1. So c in this case equals 1. In other words, what I'm saying here is it's not so meaningful when you're talking about a pattern like this, but if you went the other way, if you stopped going to the right and you went, or what would be the pattern before pattern 1, that would also have 1 square in it. Okay, so pattern 0 would have 1 square, and that's what c is, the 0th term. So now we have, if we talk about this quadratic expression, we have a, we have c. So we have a was 3 on 2 n squared. We still don't know b, and we have c. c is 1. Okay, to work out b, we can plug in some information we already have. So let's say n equaled 1, and that's the first position in our pattern. We can use that actually to find b. So plug in 1 for n, we get 3 on 2 plus b plus 1 equals 1. We can solve for b. And here you need to remember how to solve equations. I have a video on solving equations if you want to check that out to remind yourself. Here we want to solve for b. So we start by subtracting everything from the left-hand side. We want to get b by itself on the left-hand side. So we're going to subtract 1 And if we subtract 1 from the left-hand side, we have to subtract it from the right as well. So this would be 3 on 2 plus b equals 0. Then we want to subtract 3 on 2 from the left-hand side. We also have to subtract it from the right-hand side. So we end up with b equals negative 3 on 2. Okay, we're almost there. So now we have the nth term is going to be 3 on 2. That was our a, 3 on 2 n squared. Take 3 on 2 n, that was our b, plus 1. This is our nth term. What does this allow us to do? Well, remember the question was, what's the 15th pattern? Sorry, how many squares are there in the 15th pattern? We plug in 15 for n. N represents the position in the pattern. So to get our solution, we're going to do 3 on 2 times 15 squared. Take 3 on 2 times 15 plus 1. And I'm going to plug that into a calculator. So here I've plugged it into a calculator. 1.5, the same as 3 on 2, and I get 316. So 316 is the answer. That would be the number of squares in the 15th pattern if we continued this pattern on 15 times. So there you go. Did you get that yourself? Well done if you did. Thanks for watching, and I'll see you in the next one. Bye for now.